The laws of mathematics are universal because they apply to all physical phenomena, regardless of the specific circumstances or conditions under which they occur. Welcome to Opportuno, Episode 38, Mathematical Discoveries. Mathematics can help us understand more about the creation of the universe. Even as far back as when the Greek philosopher Plato lived in the 3rd and 4th centuries BC in ancient Greece, mathematics was deemed important to understanding the world around us. The Plato Academy was founded in 387 BC in Athens, Greece. Aristotle, the Greek philosopher and polymath, attended the Plato Academy for 20 years, from 367 BC to 347 BC, until he started his own school. Most people know Aristotle as being a philosopher. Aristotle was also known as a polymath, spelled P-O-L-Y-M-A-T-H, originating from the Greek word polymaths, spelled P-O-L-Y-M-A-T-H-E-S, meaning very learned in Greek. A polymath is someone that has a knowledge of many subjects. Along with Aristotle, perhaps a great example of a more recent polymath would have been Benjamin Franklin, who was very knowledgeable in many subjects, including being an inventor, scientist, writer, political philosopher, printer, diplomat, and statesman. One of Benjamin Franklin's quotes reads as follows: "Tell me and I forget, teach me and I may remember, involve me and I learn." End of quote. Benjamin Franklin's quote is a reminder that it is very important for us all to involve others in sharing what we have learned, and for ourselves to be involved, actively learning new things that can benefit us and others. Another quote by Benjamin Franklin helps us in planning priorities, reads as follows: "An investment in knowledge pays the best interest." End of quote. At age 87, Michelangelo di Lodovico Buonarroti Simoni, known as Michelangelo, an architect, sculptor, and painter, said, "I am still learning." End of quote. Continually learning and actively involving ourselves and others in new endeavors will heighten your awareness as to truly what a wonderful world this is, with many wonderful people, with everyone living together on our home planet, known as Earth. Since we have no choice but to be neighbors, as we all live in the same neighborhood, planet Earth, the more people being neighborly to others, the more wonderful this world will be. A Welsh proverb reads as follows: "A little among neighbors is worth more than riches in a wilderness." End of quote. And a Chinese proverb reads as follows: "A good neighbor, a found treasure." End of quote. When you make a mindset change and realize that everyone you meet on this planet is your neighbor, and you make a determined effort to treat everyone neighborly, you'll find friends, experience new adventures and discoveries that will help to fill your life with joy, love, contentment, and meaning. One of those subjects people learn is mathematics. Even in ancient times, mathematics was considered so important that it has been said that above the doorway of the Plato Academy was a sign that read, "Let no one ignorant of mathematics enter here." End of quote. One mathematical formula called the Mandelbrot set, spelled M-A-N-D-E-L-B-R-O-T-S-E-T, is fascinating as a logical way to take a closer look into a very small window of how the universe was created and is being created. The Mandelbrot set is a mathematical object that is defined as the set of complex numbers for which the function f, left parentheses, z, right parentheses, equals z squared plus c does not diverge when iterated from z equals 0, where c is a complex number. The Mandelbrot set is named after Benoit Mandelbrot, who introduced it in his 1980 book, The Fractal Geometry of Nature. The Mandelbrot set has a highly intricate and infinitely complex structure, and it exhibits self-similarity, meaning that its structure appears the same at different scales. It is also connected to other mathematical objects, such as Julia sets, which are also defined using the function f, left parentheses, z, right parentheses, equals z squared plus c. The Mandelbrot set is significant because it is an example of a fractal, which is a mathematical object that exhibits self-similarity and has a non-integer dimension. Fractals are found in a wide range of natural phenomena, including the shapes of clouds, mountains, and coastlines, and they have many applications in fields such as computer graphics, data compression, and financial modeling. The Mandelbrot set is also significant because it has inspired a great deal of artistic and aesthetic interest, with many people creating beautiful and intricate images of the Mandelbrot set using computer algorithms. There are many ways that the Mandelbrot set is seen and found in the creation of the universe. It is important to note that the Mandelbrot set is a mathematical object that is not directly related to physical phenomena in the natural world. It is a purely abstract construct that is defined using complex numbers and a mathematical function. As such, it is not directly found in nature in the same way that physical objects, such as rocks or trees, are found in nature. However, the concept of self-similarity, which is exhibited by the Mandelbrot set and other fractals, does occur in many natural phenomena. For example, the shapes of clouds, mountains, and coastlines can exhibit self-similarity because they can have similar patterns at different scales. The branches of a tree and the veins in a leaf can also exhibit self-similarity. The concept of self-similarity that it embodies is a fundamental property of many natural phenomena. This concept of self-similarity, which is exhibited by the Mandelbrot set and other fractals, may be relevant in the study of the structure of the universe on cosmological scales. Some cosmologists have proposed that the structure of the universe at large scales may be described using fractal models. One way in which the concept of self-similarity might be relevant in cosmology is in the distribution of matter in the universe. The distribution of matter on large scales, such as galaxies and galaxy clusters, may exhibit self-similarity, meaning that the patterns of matter at different scales are similar. This is known as scale invariance, and it is a characteristic of many fractal structures. The Mandelbrot set is a mathematical object that exhibits self-similarity, which means that its structure appears the same at different scales. In other words, the Mandelbrot set includes infinitely smaller copies of itself nested within itself. For example, if you zoom in on a particular region of the Mandelbrot set, you will see a smaller copy of the overall shape of the Mandelbrot set. If you continue to zoom in, you will see even smaller copies of the overall shape of the Mandelbrot set, and so on, indefinitely. This is one of the reasons why the Mandelbrot set has an infinitely complex and intricate structure. It is not possible to determine whether these smaller copies of the Mandelbrot set go on indefinitely, or whether they are finite at some point. This is because the Mandelbrot set is an abstract mathematical object, and it does not have a physical size or dimension that can be measured. The concept of self-similarity in the Mandelbrot set is purely mathematical and does not have a direct physical counterpart. The concept of self-similarity, which is exhibited by the Mandelbrot set and other fractals, can be observed in many natural phenomena. Examples of animate and inanimate things that exhibit self-similarity include the shapes of clouds, mountains, and coastlines can exhibit self-similarity because they can have similar patterns at different scales. The branches of a tree and the veins in a leaf can also exhibit self-similarity. Fractal patterns can be found in the growth patterns of plants and in the patterns of animal behavior. Fractals can be found in the patterns of fluid flow, such as in the movement of water in a stream or in the patterns of air flow around a wing. And fractals can be found in the patterns of electrical current flow in certain materials, such as in the behavior of superconductors. The concept of self-similarity in the natural world is not always perfect, and many natural phenomena exhibit self-similarity only to a certain extent. However, the concept of self-similarity is a fundamental property of many natural phenomena and has many applications in fields such as computer graphics, data compression, and financial modeling. The concept of self-similarity in the distribution of matter in the universe is still an area of active research and debate, and it is not yet clear to what extent the universe exhibits self-similarity on cosmological scales. There is currently no established theory that explains the creation of the universe in terms of the Mandelbrot set or any other fractal structure. Knowledge of and the use of the Mandelbrot set can benefit mankind. The Mandelbrot set and other fractals have many practical applications in various fields. Some examples of how the use of the Mandelbrot set and other fractals can benefit mankind include computer graphics. Fractals can be used to generate highly detailed and realistic images of natural phenomena, such as landscapes, clouds, and trees. They can also be used to create abstract and artistic images. Data compression. Fractals can be used to compress data, such as images or audio files, by representing complex patterns using a small number of parameters. This can be useful for storing and transmitting data efficiently. Financial modeling. Fractals can be used to model and predict the behavior of financial markets, such as stock and currency markets. Medicine. Fractals can be used to analyze the structure of tissues and organs in the human body, such as the lung and the brain, and to understand how they function. Environmental science. Fractals can be used to study the distribution of pollutants in the environment and to understand how they spread and interact with different systems. And telecommunications. Fractals can be used to design antennas and other communication devices that are more efficient and effective. These are just a few examples of the many ways in which the use of the Mandelbrot set and other fractals can benefit mankind. Fractals have many other applications in fields such as engineering, meteorology, and geology, among others. Mathematics plays a fundamental role in our understanding of the universe and the physical phenomena that occur within it. Many of the fundamental laws and principles that govern the behavior of the universe can be described using mathematical equations and concepts. For example, the laws of motion and gravitation, which describe the motion of objects and the forces that act upon them, can be expressed using mathematical equations. These laws, which were first described by Isaac Newton, have been widely tested and are considered to be fundamental principles of the universe. In addition to describing the behavior of physical phenomena, mathematics can also be used to make predictions about the future states of the universe. For example, the mathematical equations that describe the orbits of celestial bodies can be used to predict the positions of planets and other objects in the sky at future points in time. Mathematics can also be used to describe the structure of the universe on a cosmological scale. For example, the mathematical theory of general relativity, which was developed by Albert Einstein, describes the curvature of space-time and the way in which mass and energy cause it to warp. This theory has been widely tested and is considered to be a fundamental description of the structure of the universe. Overall, mathematics is a powerful tool for understanding and explaining the design of the universe and the physical phenomena that occur within it. It allows us to describe and predict the behavior of the universe in a precise and systematic way, and it has led to many important discoveries and insights about the nature of the universe. The laws of mathematics are evident in how the universe is structured. The following are a few interesting facts about the laws of mathematics. The laws of mathematics are abstract, conceptual, universal, invariant, and exceptionless entities that are used to describe and understand the structure and behavior of the universe. They are based on a set of logical and axiomatic principles that are accepted as being true, and they are used to deduce and make predictions about the physical world. The laws of mathematics are abstract because they are not tied to any specific physical objects or phenomena. They are conceptual entities that are defined and used to understand and describe the world. The laws of mathematics are universal because they apply to all physical phenomena, regardless of the specific circumstances or conditions under which they occur. They are invariant, meaning that they do not change over time or depending on the location or reference frame in which they are studied. The laws of mathematics are also exceptionless, meaning that they hold true in all cases and do not allow for exceptions. For example, the law of non-contradiction, which states that a proposition cannot be both true and false at the same time, is an exceptionless law of mathematics that applies in all cases. And the laws of mathematics play a fundamental role in the design of the universe because they provide a logical and systematic framework for understanding and describing the physical world. They allow us to make predictions about the behavior of the universe and to develop theories and models that help us to understand how the universe works. They also provide a basis for testing and verifying our understanding of the world, and for making new discoveries about the nature of the universe. The Mandelbrot set is sometimes called God's thumbprint. The Mandelbrot set is a mathematical object that is defined as the set of complex numbers for which the function f, left parentheses, z, right parentheses, equals z squared plus c does not diverge when iterated from z equals 0, where c is a complex number. The Mandelbrot set has a highly intricate and infinitely complex structure, and it exhibits self-similarity, meaning that its structure appears the same at different scales. It is also connected to other mathematical objects, such as Julia sets, which are also defined using the function f, left parentheses, z, right parentheses, equals z squared plus c. The Mandelbrot set has sometimes been referred to as God's thumbprint because of its intricate and infinitely complex structure, which has inspired a great deal of artistic and aesthetic interest. The term God's thumbprint suggests that the Mandelbrot set is a kind of signature or signature mark of the divine, and that it embodies some of the fundamental properties of the universe. Complex mathematical formulas are slowly being discovered that relate to the creation of the universe. World scholars, including scientists and mathematicians, have just scratched the surface of the genius creation of the universe. It is clear that a mathematical design, complex and not completely understood by man, can be observed in the creation of the universe. It is not a stretch to believe that if the universe was created using such complex and ingenious mathematical equations, to know there must be a higher intelligence, having much, much more higher intelligence than man, created from nothing this marvelous universe. Mathematics helps to confirm what many know to be true, is that there is a higher intelligence that created the universe, and all that is in the universe, with that higher intelligence that created the universe, is God. As is written in the first verse of the Bible, in the book of Genesis, chapter 1, verse 1, which reads as follows: "In the beginning God created the heaven and the earth." End of quote. It took the wisdom of a higher intelligence than the intelligence of man to create the universe. The following verses from the Bible, from the book of Proverbs, chapter 3, verses 19 to 20, makes it clear that God, through his infinite wisdom, created the earth, with those verses, reading as follows: "The Lord by wisdom founded the earth, by understanding he established the heavens. By his knowledge the deeps broke open, and the clouds dropped down the dew." End of quote. God's handiwork of His marvelous creations is everywhere, all about us. In the Bible, in the book of Psalms 19, verse 1, reads as follows: "The heavens declare the glory of God, and the firmament shows His handiwork." End of quote. And in the Bible, in the book of Psalms, chapter 104, verses 24 to 25, reads as follows: "O Lord, how manifold are thy works! In wisdom hast thou made them all. The earth is full of thy riches. So is this great and wide sea, wherein are things creeping innumerable, both small and great beasts." End of quote. Mathematics, as in this example of the Mandelbrot set, gives us a very tiny glimpse into the creation of the universe. For further information on the Mandelbrot set, please access the links in the description area of this video or podcast. That's all for now. The remaining portion of this video continues to show examples of fractals of flowers. Please visit opportuno.org. Thank you.